All right, that tricky number 10 that we had on that 7.4 integration by parts worksheet. So this, I should take some time to explain this and also to rectify some of the damage I'd done to block 4. You guys kind of left in reasonable good care, but let me try some other tacks. Let me show you exactly what we're shooting for. One of the options we have for integrating is, though this is not a U substitution type of problem, we don't see any internal u whose a multiple of its derivative is outside. I guess we have that x if we do the u is equal to x, and we should explore that and take a second when you work it out, but we'll find out it doesn't work as well, because if you just choose it to be x, you're just doing sine of radical u, which gets us right back where we started. So it's the radical that gives us trouble. Well, anyhow, we still can do u substitution sometimes to rewrite a function like this, so a non-u substitutional type problem. We could actually rewrite it as a product of two functions in terms of another variable and integrate it using parts. So this case, I'm going to show you how that works. So I pick u to be that radical x, which you guys all saw. And the reason that works well is because if you think of the derivative of radical x, it has a 1/2 x to the negative 1/2. You know, it has this piece that goes with the dx, so we're going to end up with something outside being multiplied by that sine of x. And if you can't see that, at least watch here. I'm going to give you the tack that you can use in future problems. So here you go. U is radical x. Now, a couple ways to tackle this. Let's be direct about it. Let's just go ahead and do what we usually do for U substitution, and we'll tackle that. But the first thing is, what's our goal with this? I mean, you replaced radical x, but the other thing is, if I want to rewrite this in another form, as a product, that means the only thing left of our integral, that dx, needs to be rewritten as well in terms of u. I need it to be something of u, and I need it to be a product so that I can do integration by parts, that type of thing. So we're going to take a derivative of that u equals radical x, and we're going to find out what dx is, solve for dx, and put it in that space I just made right there. So that's our goal. So here's u equals x to the 1/2. We're going to find out what dx is equal to, and see if we can't put it in there and make this a new integral with a product and have it in terms of u. So check this out. All right, let's do the derivative. I'm going to be pretty straightforward here. The derivative of u du dx is 1/2 x to the negative 1/2. Probably multiply the dx's over there, you know, normal stuff, and do the 2 on the left. I'm also going to rewrite that x to the negative 1/2 as 1/x to the 1/2 dx. Cool? All right, pause there for a second, make sure you're good with that. Just standard derivative and just a little rewriting. Okay, the goal is to get x dx by itself. So the reason I multiply the 2 over is for that goal. And also rewriting the 1/x to the 1/2. This will be easier than to multiply both sides by x to the 1/2. So here goes. 2x to the 1/2 du is dx. You'd think we're done, right? Well, you don't do substitution without replacing all the variables with our goal variable. We're replacing it with u's. So we need to rewrite this. Notice that x to the 1/2 in there next to du. Excuse me, that can be replaced. That's our u. So we can take out the x to the 1/2 and put in u. And so whatever I told you in class, this is probably a more direct way. Just we're writing dx in a new form in terms of u. So when I see the x to the 1/2, why not replace it with our u? There you are. We can put 2u du in for our dx. And there you go. We got our integral that's a product now, and it's integrable by parts because there's a polynomial multiplied by a trig function. We can do those. Pardon me. The way I was showing in class, which is probably confusing, this would be a good time to close your eyes, maybe fast forward if you're not interested. But do you remember what I did is I multiplied both sides? I took u and made it u squared equals x, just squared both sides. And then took the derivative implicitly, so the derivative of the left and the right side with respect to x. And we got 2u du dx, that's the chain rule in implicit differentiation, because I'm deriving with respect to x. And then derivative of x with respect to x is just 1. There you go, 2u du, multiply both sides by dx, equals 1 dx, or just dx. So the same result. And I think bringing that up in class confused some things. I also tried to shy away from using u, because I thought it would be confusing for later, but it's fine. I was making it into a. Let's just leave u in there. You guys can handle it. So there you are. That's just what I was trying to attempt. I would stick with the red stuff on the right if that makes you happy. Try it. This is where we are. We got this integral of sine of u, 2u du. Let's just do the table. It's by parts. You have a product of two integrable and differentiable functions. U would be the polynomial, trig function for dv. Do our due diligence there. Derivatives, integrals, boom, put your pluses and minuses in there. Now we're ready. Diagonal 1 minus diagonal 2 plus c. And we're almost done. We just have to put u back. So here goes. U goes back in. And we got negative 2 radical cosine over radical x. Hey, that's the whole shebang right there. And probably a lot more understandable than whatever it is I came up with in class. So thanks for those who said, hang on. Let's do that again. So that's the again. Email with other questions, especially if you have questions on my math lab this weekend. We'll see you on Monday.